So 7.5, we're going to be talking about proportions of triangles. So proportions of triangles, we have a side splitter theorem. So theorem 7.4. If a line is parallel to one side of a triangle, then it divides the sides of the triangle proportionally. So proportionally means we can set things equal to each other, okay, because we're going to have a proportion. So this is the part that's dividing the side of the triangles proportionately. So I can take AG and put it over GC and set it equal to the opposite side. So since AG should be the same as BH, then that means GC should be the same as HC. So you can see that we can create a proportion based on this information. Okay, so here's an example. I'm going to do 3 over 1 and set it equal to x over 1.5. So we have our proportion, so we're going to cross multiply. So x equals, we have x times 1 is x, and then 3 times 1.5 is 4.5. Okay, so we're doing it the same here. So I'm going to do 2x over 15 is equal to x plus 2 over 12.5. So 12.5 times 2x, so 12.5 times 2, so we have 25x equals 15. Since it's more than one thing, I need to put it in parentheses, so 15x plus 30, subtract 15x. So I have 10x equals 30, divide by 10. So x equals 3. So if I plug it back in, if I'm missing sides, 3 times 2 is 6. 3 plus 2 is 5. Okay, so we're just making a proportion based on our sides. Okay, so corollary to the side splitter theorem, if 3 parallel lines intersect, so we have our, here's one, here's one, here's one, okay, by 2 transversal, so transversal, transversal, then the segments intersected on the transversal are proportional. So we're going to create proportions. It's basically the same as what we just did. So we have our 2 over 7 from the same side, and we match it, so equals. So the 2 is on top, so the 3 has to be on top because they're proportional to each other. And 7 is on bottom, so x is on bottom. So then we solve. So 2 times x is 2x. 7 times 3 is 21. Divide by 2. So x equals 10.5. So this is 10.5 right here. Okay, so this one's a little bit different because this entire length is 40. Okay, so I'm going to do 12 over 20 is equal to, the match with 12 is x, but this, I need to take x away from that 40. So I'm going to do 40 minus x. Because whatever this is, say that was 3, and we know that whole length, so here I'm going to show. So say we have this being 3. If the whole length is 40, and I just need this length, I would take 40 minus 3 and get that 37, and that's what I would put here. But I don't know that that's 3, so that's why I'm filling it in with x, so that I can fill out the rest and solve for x. So we're going to cross multiply. So 40 minus x times 12 equals 20x. So 12 times 40 is 480 minus 12x equals 20x plus 12 plus 12. 480 equals 32x. So x equals 15. So if this is 15, if I wanted to find this length, I would take 40 minus 15, and that would be 25. So you could plug it back in and check it if you really wanted to. But this one you have to be careful because you got to do the 40 minus x because you don't technically know what this length is here. Okay, triangle, angle, bisector theorem. If a ray bisects an angle of a triangle, then it divides the opposite sides into 2 segments that are proportional to the other 2 sides. Okay, so this time we can do 8 over 12, so our one triangle is set equal to the bottom, so they're the similar ones here, to the side here. So we can cross multiply. 8x equals 6 times 12 should be 72. Divide by 8, so x equals 9. Okay, so we know that that's 9. So the bottom, so x minus 1 over the side, set equal to the bottom again, and the side. Cross multiply, so I'm going to get 9 times x minus 1 is equal to 12 times x minus 2. So if I distribute, I should get 9x minus 9 is equal to 12x minus 24. So I'm going to subtract 9x, get 3x, add 24. So x equals 5, so this length is 3, and this length should be 4. Okay, so it's just a different type of way of making proportions. So I would make sure to get a picture in of the example instead of just the words for all of these.